Imagine spending 2 entire years examining 7,500 photographs of a ship that has been lying dead beneath the ocean for more than 113 years, not simply looking at them, but studying every detail with forensic precision, matching rivet to rivet, metal plate to metal plate, shadow to shadow, and rebuilding a puzzle whose secrets had remained hidden in the Atlantic for generations. Now imagine finally completing that enormous puzzle and discovering that the picture staring back at you completely changes what you thought you knew about the most famous shipwreck in human history. That is what happened when the deep sea mapping company Magellan completed one of the most advanced underwater scanning projects ever attempted on the Titanic. What they discovered nearly 3,800 meters beneath the surface of the North Atlantic was far more than a remarkable collection of images. It challenged the accepted explanation of the ship's final moments, helped restore the reputation of a man who had been blamed for more than a century, provided physical evidence of an extraordinary sacrifice, and revealed that much of the familiar Titanic story had left out some of its most important details. For most of the 113 years since Titanic sank on April 15, 1912, the wreck at the bottom of the Atlantic remained almost impossible to study as one complete site. Expeditions had visited it, and Robert Ballard discovered the wreck in 1985, finding the ship separated into 2 major sections, roughly 600 meters apart, at a depth of around 3,800 meters. Nearly 12,500 feet below the surface and about 370 miles southeast of Newfoundland. Submersibles descended to the wreck and filmed selected areas. Remotely operated vehicles collected hours of footage. Researchers recovered artifacts and examined whatever parts they could reach. But nobody had ever been able to see the entire wreck site in one complete picture. The darkness was overwhelming, the depth was extreme, the wreck was enormous, and the available technology simply could not provide the complete view researchers needed. That limitation finally began to disappear in 2022, when Magellan sent 2 remotely operated vehicles called Romeo and Juliet to the Titanic site. Their mission was not simply to visit the wreck or capture a few dramatic images. Their goal was to map every accessible surface of the ship and the surrounding debris field with extraordinary precision. For 3 weeks, Romeo and Juliet descended to the wreck each day and moved through carefully coordinated patterns, photographing every angle, every damaged surface, every broken edge, every corner, and thousands of scattered objects across the debris field. When the expedition ended, the team had collected 7,500 individual photographs, along with 16 terabytes of visual and spatial information, an amount of data roughly comparable to 6 million books, all focused on one ship resting at the bottom of the ocean. But capturing the photographs was only the beginning. Back on the surface, advanced photogrammetry software processed the enormous collection of overlapping and geo-referenced images and transformed them into a complete 3-dimensional representation of the wreck site. The reconstruction and verification process continued for 2 years, and when it was finally completed, researchers had something that had never existed before. A full-scale digital twin of the Titanic with detail extending down to individual rivets. Researchers could examine the wreck at life size, move around specific sections, zoom into features that previous expeditions had never been able to see clearly, and study the entire site as one connected piece of evidence. Titanic analyst Park Stevenson described the result as a genuine game-changer, because for the first time, the wreck could be examined not simply as a romantic underwater ruin, but as a complete forensic scene. The most important discovery came when researchers stopped looking at Titanic as a single broken ship, and instead examined everything around it, because scattered across the ocean floor between the bow and stern sections was an enormous debris field containing tens of thousands of objects, pieces of the ship's structure, furniture, equipment, personal belongings, fragments of the hull, and countless smaller items that had fallen away as Titanic broke apart and descended. Previous expeditions had documented many of these objects individually, but the new 3-dimensional map finally showed their exact positions relative to one another, creating something close to a forensic reconstruction of the disaster. The pattern revealed where different parts of the ship had separated, how heavy objects behaved during the sinking, where materials had landed, and how the wreckage had spread across the seabed. But among all those discoveries, one particular feature immediately demanded attention, a section of hull plating, with a remarkably clean pattern of damage that appeared to show how Titanic actually encountered the iceberg. For generations, the accepted image of the collision was simple. Titanic struck the iceberg with enough force to rip a long, open wound along the side of the ship, allowing seawater to pour rapidly into multiple compartments until the ship could no longer remain afloat. That explanation was supported by survivor testimony and later investigations. But the new scan suggested something considerably more subtle instead of one enormous continuous tear. The evidence pointed toward a series of relatively narrow openings and separated damaged areas along the hull, some of them appearing surprisingly small when compared with the enormous size of the ship. Yet their combined effect was catastrophic because the damage extended across several watertight compartments, allowing seawater to move through the forward sections faster than Titanic could compensate. This distinction matters because it changes the physical understanding of why a ship that had been considered extraordinarily strong could sink after what might appear visually to be limited hull damage. The problem was not necessarily one giant gash. It was the location and distribution of the openings, combined with the ship's design and the way water progressed from one compartment to another as the bow continued to descend. The new map also gave researchers a much clearer view of the bow section, which remains one of the most recognizable pieces of the wreck, despite more than a century of corrosion and biological growth. The basic shape of the bow was still remarkably recognizable, but the scan showed numerous structural details that had been almost impossible to interpret through earlier video footage. Researchers could identify individual plates, seams, rivets, and sections of damaged metal, and compare them with the original construction plans. The surrounding debris field added another layer of evidence because objects were not scattered randomly. Their distribution reflected the ship's violent breakup and descent through thousands of meters of water. Heavier structural pieces tended to settle differently from lighter objects, while fragile materials were carried farther away, allowing researchers to reconstruct aspects of the sinking sequence. From the final resting positions alone, the Titanic wreck was no longer simply a silent monument on the ocean floor. It had become a massive physical record of the final hours of the ship, preserving evidence that had remained hidden from researchers for more than a century. And when the preliminary forensic examination of that wreck began, the discoveries came quickly. The first major revelation centered on the enormous difference between the bow and stern sections and what that difference actually revealed about the sinking. The bow section, stretching roughly 450 feet and containing the bridge, forecastle, and forward cargo holds, remains upright on the seafloor in remarkably recognizable condition. More than a century beneath the Atlantic has obviously damaged it. Iron-eating bacteria have slowly consumed portions of the structure, and some areas have collapsed. Yet the basic shape is still unmistakable. The railings remain visible, the anchors are still in position, the portholes can still be identified, and when researchers examine the bow, they can still clearly recognize the remains of a once enormous ocean liner. The stern tells a completely different story. Instead of remaining recognizable, it appears compressed and folded into a chaotic mass of twisted steel. Decks have collapsed inward on top of one another, and metal plates have been forced into angles that reveal just how violently the structure failed. For decades, the explanation for that destruction seemed straightforward. After Titanic broke apart, the stern was believed to have fallen from the surface at enormous speed and slammed into the ocean floor, with that impact supposedly responsible for the extreme damage visible today. But the explanation always contained one uncomfortable problem. The bow also fell through the same water and eventually struck the seabed, yet it remained dramatically more intact. Before the new mapping project, there simply was not enough detailed evidence to confidently challenge the traditional explanation. The three-dimensional digital twin changed that completely. When researchers examined the stern using the precision provided by hundreds of thousands of photographs, they discovered that the damage pattern did not resemble the kind of destruction expected from one sudden impact with the seabed. Instead, it matched progressive structural failure occurring during the descent itself, meaning the stern was already tearing itself apart while it was still falling through the Atlantic. Long before it reached the bottom, the structure was collapsing under forces generated during the breakup and descent, rather than being destroyed, primarily by one final collision with the seafloor. The scans also allowed researchers to examine the final moments of Titanic in a way that earlier expeditions simply could not. Once the stern began separating from the bow, the enormous pressure acting on the weakened structure caused different sections to deform and collapse as the ship descended. The new model made it possible to trace those patterns across the wreck and compare them with the known sequence of events from survivor testimony and earlier investigations. Details that once seemed disconnected could now be viewed together as parts of one physical story. The result was a much more precise picture of the ship's final destruction. Not a single dramatic instant when the stern simply dropped and shattered against the seabed, but a prolonged sequence of structural failures unfolding during the descent, with the wreck itself preserving evidence of those forces more than a century later. The Titanic had not simply fallen apart when it reached the bottom. Much of the destruction had already happened on the journey down, and the new digital evidence finally allowed researchers to see that process in extraordinary detail as the iceberg damage caused the forward compartments to flood and forced the bow deeper and deeper into the Atlantic. The stern began rising farther out of the water, creating enormous pressure across the middle section of the ship. Titanic had been designed with expansion joints that allowed the hull to flex slightly during heavy seas, but those joints were never meant to handle the forces created when one end of a 46,000-ton ocean liner was being pulled beneath the ocean, while the other end was rising toward the sky at an increasingly steep angle. The keel began bending under the strain. Hull plates started separating and sections of the decks began tearing apart. But this was not the sudden clean snap that later films would repeatedly show. The new evidence points instead to a slower and more violent process, a progressive structural collapse that continued over several minutes. While people were still alive aboard the ship, the enormous stresses moved through the structure and gradually transformed the middle of Titanic from a functioning section of an ocean liner into the point where the ship was coming apart. The debris field provided some of the strongest physical evidence for that conclusion. By recording the exact position, orientation, and condition of thousands of individual pieces scattered between the bow and stern, researchers were able to reconstruct the breakup almost like a story written directly into the steel. Hull plates found across the seabed showed signs of being pushed and bent outward instead of being cleanly sliced apart, suggesting that the metal was progressively forced beyond its limits rather than instantly fractured. Sections of the decks appeared to have been pulled apart instead of simply snapping, while portions of the keel showed evidence of twisting before they separated completely. Together, these details pointed toward a ship gradually tearing itself apart over minutes rather than breaking apart in one instantaneous event. The forces began around the weakened central area and propagated outward as the bow continued sinking and the stern continued rising, producing the progressive destruction that ultimately separated the two enormous sections. This understanding also changes how we picture those final moments. Because the breakup was not simply one dramatic event followed by the stern dropping intact into the darkness, the ship was already undergoing severe structural destruction. While the separation was developing, every movement increased the strain on the remaining connections, and every new failure transferred greater forces into the sections that were still holding together. The digital reconstruction allowed researchers to examine that process through physical evidence preserved across the wreck and debris field. Instead of relying entirely on cinematic interpretations or memories recorded more than a century ago, the pattern of bent plates, twisted keel sections, and separated deck structures provides a much more detailed account of how Titanic failed. The ship did not simply split and fall apart in a single instant. It progressively disintegrated under forces that continued building until the connection between bow and stern could no longer survive, leaving the two sections to descend separately into the deep Atlantic. But the scan revealed something even more remarkable inside the engineering story, evidence that the men below deck had continued working long after the iceberg struck. The engineers and boiler room crews remained at their stations for more than 2 hours, while water continued flooding the ship. In Boiler Room 2 alone, there were 35 men, and not one of them survived. They stayed behind because the generators had to keep operating. The electricity they maintained powered the lights across the ship, supported the davit motors used to lower lifeboats, kept the wireless transmitter sending distress signals, and powered the pumps attempting to slow the flooding. Their decision meant that people on the upper decks were able to continue evacuating with light and communication instead of being plunged into complete darkness. And the evidence found on the wreck gives that sacrifice a physical presence that written accounts alone could never provide. The findings also gave greater weight to the role of Chief Engineer Joseph Bell and the men under his command. All 25 of Titanic's engineers died, while the wider engineering department, including stokers, trimmers, and electricians, suffered devastating losses as well. The open steam valve, photographed by Magellan's remotely operated vehicles, provides a physical clue connected to the work these men were carrying out during the final hours. Their sacrifice helped preserve the systems that kept the evacuation functioning. If the lights had failed much earlier, the lifeboat operation would have become far more chaotic. And if the wireless system had stopped transmitting, sooner rescue vessels might not have received the distress signals in time. Every minute of organized evacuation and every message that reached the Carpathia depended on systems that these men continued operating while the ship around them was being consumed by water. The digital reconstruction also brought new evidence to one of the longest-running controversies surrounding First Officer William Murdoch, who had been accused for generations of cowardice during the final moments of Titanic. Some accounts claimed that he had shot passengers before taking his own life, leaving a damaging reputation that followed his family for generations. But the new scan could physically confirm the position of a lifeboat David on the boat deck. And that position is consistent with testimony from crew members who said Murdoch was actively helping launch a lifeboat when a wave swept across the deck and carried him away. The scans cannot establish every detail of what happened to individual passengers, but the physical evidence gives meaningful support to the account that Murdoch remained at his post attempting to save lives rather than abandoning his responsibility. After more than a century, the wreck itself has provided evidence that may finally allow his final actions to be understood differently.